Welcome back to All This Math. This is Professor Parker. And for this lesson, we're doing some Praxis prep recap. All right. So this is one of the problems that I went over this past weekend when I was doing my Praxis prep session with some teachers down in Baltimore. And I just wanted to go over this either for their benefit or anybody else that's out there watching. All right. So we have 3 2/3 minus 1 4/5. All right. So this is a pretty standard subtraction problem dealing with mixed numbers, though. Mixed numbers because the numbers consist of a mixture of two types of numbers. We have an integer and we have a fraction. All right, integer and a fraction. So 3, and then we have 2/3. 1, and then we have 4/5. There's a few ways to do this problem, just like with a lot of math problems. There's a few ways to do any math problems, right? Because this is a test, right? We're preparing for a test, and we don't got all day to answer problems on the test. So we want to work smarter, not harder sometimes. All right, so we want to implement some test-taking strategies. So one thing you could do is using the calculator that's provided to you on the screen within the online version of the test. You could convert these to decimals. So meaning 3 2/3 could be converted to a decimal. 1 4/5 could be converted to a decimal. Then at the same time, you could convert all of these answers into decimals, and then you just see which one matches up. All right. So what you do is you grab your calculator, right? And make sure that your calculator is in a mode where it's not keeping the fractional representation of the numbers, because some calculators they have a feature where they can give you the answer in fraction format. But for what we're doing, we actually want the answer in decimal format. So what you do is, let me get my marker. So 3 2/3, right? So there's a 3 and there's a fractional part. Now the fractional part is going to be the decimal. So in order to find out what decimal this is, you do 2 divided by 3. You always go top down. And remember, a fraction is just a division problem. That's all a fraction really is, right? It's another representation of a division problem. This top number, which is your numerator, divided by the bottom number, which is your denominator. So 2 divided by 3. So you throw that in your calculator, unless you have the fractional equivalence memorized, which would be cool too, because then you wouldn't even need the calculator, right? But you do 2 divided by 3, and that equals 0.6 with a whole bunch of 6's, right? And then all the way at the end, there should be a 7. You should round that off to 2 decimal places. 2 decimal places should be sufficient. So 0.67, right? That third 6 is greater than 5. So it's going to make the 6 to the left of it round up and become a 7. So 2/3 can be rounded off to 0.67. And this is something you should memorize too. 2/3 is equivalent to 0.67. All right. So that means 3 2/3 is going to be the same as 3.67, right? Because 2/3 is the same thing as 0.67. So the 3 is still 3. 2/3 becomes 0.67. And how do I know that? Because my calculator told me 2 divided by 3 is 0.67. All right, and we're going to do the same thing with 1 4/5. Now we know the 1 part is just a 1. So I'm going to put my minus sign and I'm going to put my 1. And then 4/5, in order to get that, go back to your calculator. If you don't know 4/5 equivalency memorized by heart, you do 4 divided by 5. Which is 0.8. That's a terminating decimal. It stops at 8. It's 0.8. So 4 out of 5, and as you give a quiz to your students, you know, there's 5 questions on it. They score 4 correct, get 4 correct, 1 wrong, they got an 80, right? 4 divided by 5 is 0.8. All right, so this is 1.8. So then you put that in your calculator, you just do the subtraction, right? Do the subtraction. You do 3.67, right, minus 1.8. So 3.67 minus 1.8. Equals 1.87. All right, so 1.87, but that's in decimal format. These answers are all in mixed number, fraction, mixed number, and fraction format. So what I could do is I could convert each of these answers into decimal format as well. So first I'm going to convert answer choice A, 1 13/15, into a decimal. So I go to my calculator, I do 13 divided by 15. Remember, top down, not bottom up. We're not doing 15 divided by 13. We're doing 13 divided by 15. We go top down. We follow gravity, right? We go down. All right. That equals 0.8 and a whole bunch of 6's, right? A whole bunch of 6's. Now I can round it off to 2 decimal places. If I do that, I'm going to have 0.87. So this is equal to 1.87, right? And isn't this what I got? When I converted these into decimals and then I subtracted, I got 1.87. So if we taking this test, right, and you use this method, you can stop right here because you know that this is the answer, because this mixed number is equivalent to the decimal that we got when we converted these mixed numbers into decimals and then subtracted. So choice A is the correct answer. So you can stop right there. You don't even need to convert let choice B, C, and D into decimals because it don't matter. You already got the right answer. All right. So you get the right answer. Make sure you check A or bubble in A or choose A on your keyboard and then go into the next question. All right. Now, let's say you wanted to use the traditional method of subtracting mixed numbers. Let's say you want to do that. That's fine. Let's do that. Let's set it up. Now, when I set up these problems, I typically will set the problem up vertically, right? This 3 2/3, which is what we call the minuend, right? The first number in the subtraction problem is called the minuend. The second number in the subtraction problem is called the subtrahend, all right? In case you were wondering that. And the answer is called the difference. So you got minuend, subtrahend, which gives you the difference and then leads to the difference. So the minuend goes on top, right? So we got 3 2/3. And then the subtrahend goes on the bottom. So we got 1 4/5, right? Put your minus sign and draw your line, right? Now, as I look at this problem, I size it up, I assess it. I look at the fraction parts. I notice something. My fractions do not have common denominators. That's an issue. In order for us to do subtraction or addition with fractions or mixed numbers that include fractions, we must have common denominators. We don't got common denominators right here, right? We got a 3 and we got a 5, all right? Now, we got to think to ourselves, what would a common denominator be between 3 and 5? The common denominator is the smallest number that 3 can multiply into and 5 can also multiply into. So it's a number they have in common or that they share. The number is 15. The number is 15 because 3 times 5 is 15 and 5 times 3 is 15. So 15 is the common denominator. So what I'm about to do is this. I put an equal sign, This 3 don't change, right? That's the whole number part. This 1 don't change, right? This 3 denominator changes to a 15. And because this 3 changes into a 15, this 2 got to change. Now the question is, what's the 2 going to change into? If you do 3 times 5 to get 15, you would do 2 times 5 to get 10. Whatever you multiply that original denominator by, you got to also multiply the original numerator by the same number. So I'm multiplying the bottom and the top both by 5. So I do times 5 times 5. All right. Now over here, the common denominator is still 15, right? Now, 5 times 3 gives me 15. So now I got to say, well, what's 4 times 3? I got to multiply the top number by 3. So I multiply the 4 by 3. That gives me 12. All right. Now, I got common denominators, right? So I should be ready to subtract. But I got another issue. When I look at this, I'm like, okay, hold up. Using this method, we can't subtract a bigger number from a smaller number using this method because we can't say 10 minus 12 and get negative 2. We can't do that using this method, all right, that we're using. In this method, the minuend or the top fraction must have a bigger numerator than the bottom fraction, right? Using this method. Now, what do? We borrow. We're going to borrow from this 3. We're going to borrow from this 3. All right. We're going to borrow a whole 1 from this 3. So this 3 is going to turn into a 2. Cross the 3 out, write a 2. Right. So we borrow from the 3. The 3 turns into a 2. Now, but where does that 1 go? That's the question. Where does that 1 go? A couple of people stayed at the class and had a couple questions about this, and they were excellent questions. It forced me to think more deeply about how to really explain it. So I'm glad that they asked those questions. The 3 turns into a 2, and that 1 gets added to this 10/15. But you can't just add 1 like that, right? What I want to do is I want to convert 1 into a fraction that has a common denominator with 10/15. Again, I want to convert this 1 that I borrowed from 3 into a fraction that has a common denominator of 15. Now, something I know about the number 1 is that 1 is equal to any fraction that's got the same numerator and denominator. Again, 1 is equal to any fraction that's got the same numerator and denominator, meaning 1 is the same thing as 4 out of 4. 1 is the same thing as 10 out of 10. 1 is the same thing as 9/9. 1 is the same thing as 100 100ths, right? So if I need a fraction that has a denominator of 15, but that's equivalent to 1, then can I say 15/15 is equivalent to 1? Because it is. That's one way to, that's one out of an infinite number of ways to represent 1. 1 can be represented a whole lot of different ways. That's one thing we got to remember. 1 can be represented a whole lot of different ways. A lot of fractions, all fractions can be represented a whole lot of different ways, actually, too. That's something else to think about. But in this particular case, I want to manipulate this problem to make it do what I needed to do, right? So instead of saying plus 1, I'm going to say plus 15/15. That's going to look like that. And then the 2 I got, I write my 2, and then I do 10/15 plus 15/15. Altogether, how many 15ths is that? That's 25/15. That's 25/15. So I got 25/15. And then this bottom mixed number, that don't change. That's still 1 and 12/15. That's still going to be 1 and 12/15, right? Let me slide over here to make sure you can see everything, right? So now, what I got is, I'm going to extend this line. Now I'm ready to actually subtract. I'm ready to actually subtract now. I got common denominators, and my upper numerator is bigger than my lower numerator, all right? So I do my 2 minus 1. That gives me 1. And then I do 25 minus 12. Because remember, we never subtract denominators, just like we never add denominators. Because really all the denominator is just, it's like a unit of currency, right? It just tells us what thing we're dealing with, or like what is the medium of exchange. Like if you say you had $12 and you spent $5, you do 12 minus 5 to figure out how much money you have left. You just do 12 minus 5. You don't subtract the word dollars from the word dollars, right? Because you have $12 minus $5 equals $7, right? So if I got 25/15 and I'm subtracting 12/15, the 15th is just the unit of denomination. That's why it's called a denominator, right? So you never subtract those. You never add them either, right? You multiply or divide them, but we don't subtract or add them, right? Because it's just like a unit that tells us what unit we're dealing with, right? What we care about is the actual amount or the quantity, which is the numerator. So I got 25 of these, and I'm taking away 12 of these. So 25 take away 12, we do the math. 25 take away 12 is going to be 13. So 1 and 13/15, right? And then we look back over here. That was our answer. Answer choice A, right? So if you want to go through all this, you can do this if you want to, right? It's important to know how to do this math because you may need to teach it to some young people, or this may be relevant to another skill that they're trying to develop. And by you having these skills, then you can have a mathematical conversation with them about why certain things in math work the way they do, right? But for the purpose of the test, you may want to just work more efficiently and just say, all right, listen, I'm about to just convert these into decimals, use the little calculator to convert these into decimals. And then I'm going to do the subtraction, 3.67 minus 1.8, and I'm going to get 1.87. But then I go to my answers, and I'm like, wait, hold up, though. None of my answers are in decimal format. No need to worry. All you got to do is do the same thing you did up here. Convert each of these answers into decimal form and see which one matches up. That's all you got to do. All right? So that's about it for this. I hope this makes more sense now. And go get some practice. Challenge yourself to do some problems like these. Make some problems up. And just do a bunch of subtraction problems and then mix it up. Do some addition problems too, right? In order to get ready for the test. All right. So go ahead and get some practice and I'll catch up with you on the next video. Peace.